Welcome to our Vision Campus. Our topics for today: what is a vision system? How is this kind of system structured? What are the benefits of a vision system and where vision systems are used? The most powerful image processing equipment known as a vision system is right inside your head. It's your brain. A portion of this miracle tool is working around the clock on image identification, processing, and interpretation. Yet something that the brain seems to handle effortlessly is a real challenge for machines. Ultimately, all artificial vision systems are trying to achieve the image identification performance of the brain for a very special application. Nowadays, these systems work astoundingly well, all at high speeds and completely inexhaustibly. I would like to provide you an example from the food industry to illustrate what I mean. When it comes to cookies, we are quite picky. We expect top quality at an adequate price. The cookie is always supposed to have the same shape and color. If it's a chocolate chip cookie, the chips are supposed to be distributed evenly. A lot of manufacturing know-how is necessary to achieve a result that meets the expectation of the customers. A vision system in the production line helps to constantly monitor important parameters of the product. It identifies deviations and production errors to prevent defective cookies from ever making it into the packaging in the first place. And of course, those cookies should always taste good too. Cookies are just one of the many examples of products that require quality control using an image processing system. Using cutting-edge camera technology, companies from various industries can ensure fast, automated production and quality control, boosting efficiency and with it utilization of resources and profits for the long run. How is this kind of vision system structured? Let's look at the hardware first. The camera is pointed at the cookie. One of two different types of cameras, either an area scan or a line scan version, are used depending on the type of inspection task. A line scan camera has one single light-sensitive line known as the line sensor. It is used to record the image line by line. An area scan camera has an area sensor which records the large area simultaneously in its entirety. Line scan cameras piece together the image from a large number of lines. This process is a bit comparable with a flatbed scanner that also records the image line by line and then forwards it to the computer. It works well when a conveyor belt is used to move the objects to be inspected. If, for example, I want to check a web of cloth for tears or faults, then a line scan camera is the right choice. An area scan camera has an area sensor and records the large area image simultaneously in its entirety. The process is fast, but if the object is moving quickly, such as on a conveyor belt, there can be motion blur. Let's imagine I want to check the size and shape of our cookie. An area scan camera is a good choice for this. Lenses are very important accessories for vision systems. Every camera needs a lens with certain properties in order to choose the appropriate field of view and to image the object in clear focus to the sensor of the camera. Depending on the application, cameras are equipped with different lenses to fulfill the requirements of the inspection task. To record a good image of our cookie for inspection, we need a light source to illuminate the cookie. Let's presume we want to decorate another cookie solely with red chocolate buttons. If the task is simply to differentiate the blue ones from the red ones, for example, then a red light should be used. The red buttons reflect the red light completely and thus appear to be very bright, while the blue ones primarily absorb the light and appear as dark. The light source is thus another important component of a vision system. For this inspection task, a monochrome camera is fully sufficient. Color cameras should be used in situations where multiple colors are being checked, such as for checking the print on the cookie packaging. Within the camera, the brightness information for our cookie acquired by the sensor is processed into an image. That image data is then transmitted to the computer for analysis via the interface cable. Everyone wants compact solutions that are as simple as possible. To accommodate this, it's possible to use the same standard PCs we all have on our desk, or to opt for a highly compact embedded PC or a modular microprocessor system. Another option is an intelligent camera, where the computer is already integrated into the camera's housing. So that's the hardware. But what task is the computer performing to process the image data? The software determines this. For simple inspection tasks, image processing software configured by the user is often sufficient. If the task is more complicated, then in some cases a custom solution is required. A good, well-thought-out vision system featuring a camera, a lens, light source, interface, computer and software makes it easy for the user to monitor the production process and intervene when faults arise. When working with fully automated production monitoring, the vision system can also send control signals to a machine to sort out the bad cookies. Our cookie example is typical for an application involving quality control in the food industry. Vision systems are used in many other areas, such as medicine, traffic control and monitoring, and in the retail field. I hope I've been able to shed some light on the topic of vision systems, components, and potential applications. Thanks for watching.